I'll do red. Second. D first. Plus. It could have been, didn't have to be though. Ooh. Would that be the multiple choice answer? What factors out? Oh, yeah. How many of them? Come on, you guys remember this from the AP guys, right? They're not going to give you that. They're going to give you something that looks kind of like that and is a little bit wrong. And so you're going to be like, I made a mistake. And be wrong. Right? Seriously. So easy. To just assume that when they wrote something close that you were just a little bit off. Instead of taking time. Done. No! What are they going to do? Simplify all the stuff on the inside. After you pull, well, because now it's just to the first power, so boom, boom. You just can't do it here because it's to the fifth power, so it doesn't properly work. Does that make sense? If you put in the -2 now, you're putting in 32, and that doesn't really work because you're putting in a 2 to the 5th, and that's not good. If you put it in now, you're putting in a 2 to the 1st, and you're good. Sorry, I got distracted. -2x cubed minus 30x cubed, right? Right, -2x cubed and -30. And then we have plus 34. Oh, but first we have a plus 15x squared. No common factors. Oh, I just lost my sign. Stink. Oh, it's just times. But it was a -32, right? We're boxing it. Okay, done, 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 done. They don't give you cubes. Not in this one. They would give you squares, and then it would be something where this would simplify down even more, and then it would look totally different than this, and then you would be like, it's never right, and it's right. But anyway, go team. What's the idea of chain rule? Inside and outside. And inside and outside are what types of functions? Compositions of functions. Good. Compositions of functions. F of g of x. And so we're thinking of outers and inners, and we're having to take derivatives, right? So, which of the notations are you least familiar with? The first one. Get them all down, but then we need to talk about that first one. Because the AP guys I've been seeing the last couple years are using the first one a little bit more than I would like. No, it's not so much that, but remember how they can give you problems with like clues and you have to be able to interpret the clues? Does that make sense? I'm seeing kind of more and more, not that it's like tons of problems on the test, but they're going deeper into the content, and by going deeper into the content, we need to understand the first notation too. That's the struggle. Did I already say happy Friday? Happy Friday. Me 3. Although this is not the weekend for napping, sadly. Too much going on. What? What's going on? What, not sleeping? Top of the world? guys, when's the chapter 2 corrections due? Yep, don't forget. Okay. All right. Let me dual page. How does the first notation work? How does the first notation work? Like this. Like this. If I take an original function, this is technically like a decomposition of functions. Ooh, pre-cal. Why do I know? I just taught it today. It's so ironic how things just... Anyway. Decomposition of functions is breaking down a composite function into its pieces. What would the original function have been for this guy? Can you guys see him? Is he too small? Lo siento. Give me a sec. I'll make him bigger. Yep, just like that. Story of my life. Okay, what's the original function? F of g of x is equal to 1 minus 1 over 1 minus x. Okay, that's the original function. They broke it down into its pieces. The outer function is 1 minus 1 over u. The inner function is 1 minus x. They're trying to find, you're trying to find, I should apologize, the derivative at x equals negative 1. So here's the dealio. Yeah. U equals g of x equals... Maybe that's not my original function. So my original function would be just x minus 1. That's boring. Let's just make it 1 minus x. That was the problem. Let's make it 1 minus x. We'll change the problem. Okay. So, if we were to find dy du, do you guys get that that would be 1 plus 1 over u squared? Does that make sense? dy du says take the derivative of y with respect to u. The derivative of y with respect to u is just take the derivative as is. Wait a minute, hold on, who's not there? What's the derivative of 1? Good. So the derivative would be 0 minus, how did I do this derivative so fast? My ones that always do the quotient rule every single time. I'm not judging you. U to the negative 1. And so I said minus u to the negative 1. I brought down the negative 1, made it a positive, and I got u to the negative 2. Okay, anyway, long story short, that's dy du. Okay? How do you find du dx? Where do I look? To the y equals? No, to the u equals. Du dx, take the derivative of u with respect to x. So what's the derivative of u? With respect to x? Negative 1. I put it all together and say that the derivative of f of u is equal to dy du times du dx, which would equal dy dx, and how that works out in this problem is take the 1 over u squared times the negative 1. I'm done! No. What were we wanting the derivative in terms of? So then to finish this off, we would go ahead and have negative 1 over u, who is 1 minus x squared. Does it work? Yes. Is it the only way? No. But does it work? Yes. It's looking at the outer function only in terms of u, saying who are you apart from the inner function. Looking at the inner function totally apart from the original. And then realizing if you put their two derivatives together, dy du times du dx, differential notation says that gets the dy dx you wanted from the beginning. And technically from the beginning, you wouldn't see an f of u. Technically from the beginning, you would see an f of g of x. U is kind of, can I say a man-made construct? Something that we make in order to make it easier. But guys, let's be honest. How many of us actually solve chain rule that way? We don't. Other math teachers. Is it Einstein Academy in Santa Clarita? Who was that kid? Where was he going? I think he was going to Einstein Academy. they would teach every single chain rule problem like this. Not exactly like this, but with this idea, using W's and saying who is U in terms of V, who is V in terms of W, who is W, whoever was the last guy in terms of X, and then taking the derivative piece by piece. It was crazy, but the kids always got it right, but it made simple problems so long, and I was like, ugh, maybe someday I'll change how I teach it. But for right now, how do we take the derivative of something like this, f of g of x? Even though this notation is good, and it's valid, and it's true, how do we take this guy's derivative? Minus 1, yeah, we could make it that way. We could do quotient rule. But couldn't we just go ahead and tackle it all at once and say, oh, that's going to be positive 1 u to the negative 2 times u prime is negative 1, and we end up with negative 1 over 1 minus x squared. Same thing? Different process? What rule am I technically using, or what version of the rule am I technically using? Quotient rule, I suppose. I was thinking more I'm using these two in the sense of take the derivative of the outer, realize there's an inner, and when you see an inner, don't forget your u prime. It's a trick, it's a shortcut, it's not technically the definition. That would be back up here with the differentials. Anyway, just having us do one with the whole, like, hey, let's see it in terms of u, and by the way, there's this u, that's this other thing, and then how to put the whole thing together. That notation does work. It's not bad, but anyway. It gets to the idea, it just takes a lot longer. What's going on here? Why do I have a 3-link chain? What's that talking about? Yeah, because it's not an f of g. What is it? Technically. How would the chain rule go for this? Like, not even looking at that. Because every now and then you given clues, you might not have a function. How would the rule itself work? Keep going. When do we stop? Who would be the inner? X prime. It's 1. We're done. Right? X prime, it's done. It's 1. So then how does that apply to this guy? How should most calc students rewrite this to make it easier on themselves? Why did I put parentheses here? Yeah. Get 30 seconds ahead of me. You guys got this. Derivative of the outside, keep the inside. Peel it off. Derivative of the outside, keep the inside. Peel it off. Derivative of the inside. How do we know when to stop? Ready, my Matryoshka dolls? Right? Who is the outside? To the 1/3. We brought down the 1/3, made it negative 2/3. Didn't change anything else. Then if we totally ignored the 1/3, what was next? 17 minus cosine of, technically it'd be like a v. It'd be like a u to the 1/3 and then 17 minus cosine of v, if you want to think about it that way. We took his derivative, right? Positive sign? Positive sign of 3x. Then what? Then there was a 3x. I take the derivative. I know he's not colored because that guy graduated and never colored my last one. It was so sad. Derivative of 3x is? Then what do we do? We're done, right? No more left. If some of you guys ever do a 0, who would be inside 3x? Not 3. Who would be the inside? X. And what's the derivative of x? 1. That would be our last one, if you want to think about it that way. We should rewrite this, though, just to be nice, right? So we'd end up with, anybody get 3 sine of 3x all over? 3, well, yeah, I suppose so. There you go. How do we do a 2/3? Not that they couldn't write the 2/3, whatever they could, but good. Cubed root of 17 minus cosine of 3x squared. Dun, 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 dun. Could they possibly use any of our trig properties to rewrite it and make it confusing on us? Probably not. It's a 3x, no. They would for a double angle, but not for a triple. Riley? My g of x for this one, if I was to like write it out. Let me do a quick new page real fast and dual page it. If we were doing it like the kids in Einstein Academy, we would do something like f of u is equal to, hold on, f is equal to u to the 1/3, u is equal to 17 minus cosine of v, v is equal to 3x. That's how they would do it. But as far as our notation, it would be f of x is equal to g of x is equal to h of x is equal to. And the reason why this is more confusing and why they're using u's and v's and w's, etc., is because now it's like all x's, and you're like, ugh. Like it's just more confusing than thinking of using the primes. But does that make sense? Cool. Let me keep going with that EW, just because a few of you guys really do make a lot of mistakes. Not too many, but a few of you guys make a lot of mistakes on this. So if f of u is u, if u of v is that, and if v of x is that, how would the chain rule derivative work? It'd be a dy du times a du dv times a dv dx. You're done. How would it work? You would end up with, take his derivative, 1/3 u to the negative 2/3 times, take his derivative, 17 is just going to be 0 sine of v times, take his derivative, 3. How do you finish it off? Who's v? 17 minus cosine of 3x. Who's u? 17. No, I just said that wrong, didn't I? Sine of v. It's been a while since I tutored. I'm sorry. It's been like 5 years. Who's v? 3x. There you go. And who's u? Minus cosine of v, and who's v? Like maybe you guys can see how this is a very systematic way where you'll never get lost as long as you get in the habit of always figuring out who each of your pieces are. And then when you get down to this, like you're right, you just have to go figure out who to plug in where. Like it's good, he couldn't do derivatives fast. Like he always got them right every single time. And he was a smart kid, yeah, but he would make little mistakes all the time. He never made it with chain rule. He just had to do the process every time. I don't know. Good and bad. Good and bad. If you ever have to teach calculus or tutor it, this is a way that a kid that makes lots of common mistakes, if you give them a system and make them really, really trained on it, there is a way that even, well, I don't know, not even, but anyone can do chain rule. All right, what's going on here, cool kids? Actually, pause. You don't need me. Go. You don't need me. Go. I would do an f of g of h. F, G, H. Of x. Oh, sorry, I thought you just meant that part. I thought you'd already dealt with the other part. It'd be an f of g of h of j. What am I doing? The second D first? Sadly, there are some trig properties that we could go looking for that one. Ugh. I don't know if I want to do them, though. Could we use them? I don't think we could use them. I know, you're all looking at this one down here. We could do a cosine, cosine, sine, sine. No, not much. What am I doing? No? Nobody? You didn't realize this is the exact same thing as secant of 2x? What's 1 plus tangent squared? Secant squared. What's the square root of a squared? An absolute value. What's the derivative of the absolute value of u? Absolute value of u over u times u prime. Dun, 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 dun. Not completely wrong, completely differently. Could you make it match? No? Why not? I think it would have some trig properties, I'm pretty sure, yeah? What do you guys do? The boring way of an f of a g of an h of a j? So f prime of x is equal to 1/2 with a negative square root of 1 plus tangent squared of 2x times. You have to bring down a 2, so then you have 2 tangent of 2x times. Then you have a secant squared of 2x times 2. All right. That 2 simplified with that 2. That's fun. So then you would end up with a tangent of 2x secant squared of 2x all over a, yeah, thanks. Up top, right? A 1 plus tangent squared of 2x. You guys, you would have been fine. Because couldn't you have just kept on going and been like, wait a minute, this is somebody special? He's a secant squared of 2x? And then you could go ahead and square root of squared single That's what I was thinking. Because that's that's always a positive. Because you could simplify, but you would need to keep it always positive, right? You have to maintain the meaning. So like right here, Maggie, we could almost cancel out a secant 2x and a secant 2x, but that's always positive and that's always positive, and secant isn't always positive. So we have to keep the meaning. Does that make sense? So positive, positive. I need it when I cancel out to still always have to be positive. Oh, that's a old, should be an Algebra 1 property, even though I know when I taught Algebra 1 I didn't do it like I should. I mean, I did it a little bit. Because you need to always stay positive when you square root, Riley. Yeah. You guys grab that. Ooh, parametric equation. This is fun.
I didn't see That makes more sense.
That's not a bad thing. Yeah. If it makes sense, go for it. In pre-cal, Riley, did you use like U's and V's and W's at all? Does anybody else like the idea of the U's and V's and W's? Okay, no. You just keep going, and I'll... Actually, no, Riley, I don't want to set you behind. She just showed me hers where she did U's and V's and W's. Okay, shh. Go. Kind of. Go. I'll do it as though it was...
Wait, I do want to be a teacher eventually. All the answers are online. Right? No, all of this is online. He probably doesn't know that. No, because if he makes the packet, it's going to get worse.
It's fine.
I think it's fine.
If you want to see the U's and V's and W's, there they are. You would break it down piece by piece by piece by piece and say, who's your derivative? Okay. Who's your derivative? Okay. Oh, who's your derivative? Okay. Who's your derivative? Okay. And then plug in everybody. Who's U? Use this guy with that guy and that guy plugged in. Who's V? That guy with that guy plugged in. Who's W? That guy. Dun 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 dun. It helps you separate the work and not have to necessarily like inner, even though that's shorter. I might actually do that with AB this year. I've been pondering it. Hey, what do you guys see about parametric equations? Remember those? X of t, y of t? x sub 1 of t, y sub 1 of t. From what we just saw, that dy dx is dy du times du dx, does it make sense that dy dt could be dy dx times dx dt? Right? And if that's true, then if I'm trying to find dy dx, it would just be dy dt divided by dx dt? Ooh. Wait a minute. So couldn't we rewrite this to say that dy dx is equal to y prime of t divided by x prime of t? Not really at all, but you can remember sort of, kind of, maybe?
Not really at all.
It's not where it comes from, but you can remind yourself of that. I don't know. Anyway. Now, the logic gets a little bit harder when you get down here to the second derivative. The logic gets a little bit harder when you get down here to the second derivative. Because then you're like, second derivative, okay, take what you just found, dy dx, and take a derivative again. But the problem is, to take a derivative, you can't do a d dx. You have to do a d dt. And if you do a d dt, maybe you guys at least can tell by the notation, that would be a d squared y over a dx dt. Like, what's, and and trying to figure it out gets a little bit messy after that. Or maybe it doesn't. Because if you were to take the derivative, you would have a d squared y over a dt dx multiplied by the reciprocal of a dt over dx. And when the dt's reduced, and you would end up with a d squared y over a dx squared. What? But here's the struggle. Aren't you just going to go take another derivative and be like, dun, 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 and meanwhile, you are completely ignorant of the fact that you are wrong. Because you can't just take a derivative. You have to also divide by an x prime. But there's no pretty way of showing that. Sorry. You can write him as an x prime if you want. d dt, dy dx, all over, there you go, x prime. That's pretty. So when we get here, how do we take a derivative? A derivative? They want a second derivative. Psh, we're smart. We know to get to the second derivative, you have to find a first derivative. How do we find dy dx? d dx? Nope. Oh. d dt? Yes. Y prime over x prime. You saw why the notations worked on the page before, but let's go ahead and do it. If we can just memorize them, to be honest, without even thinking the notations, for most of us it'd be easier that way. We just have 4t cubed minus 6t squared all over 2t, right? Can we simplify that? Yes, please. Wouldn't we end up with 2t squared minus 3t? But that's the first derivative. What do we need? And to find the second derivative, take d dx. We can't. Oh. Take d dt, the derivative of the guy you just found, but the notation would break down. What else do we need? An x prime of t. Then we would get 4t minus 3 all over, who was x prime again? 2t. If you're trying to solve for it such that t equals 1, four minus 3 is 1 half. What does this mean? The slope of a parametric path at t equals 1 is equal to 1 half. Not the slope, I apologize. The concavity of the path when t is equal to 1 is positive, is up, I should say. Yeah. Yeah. I'm just trying to think of why not just get rid of all the t's, no big deal, take the second derivative the normal way. But how could you plug in 1? Now, if you did eliminate the parameter, it wouldn't be totally bad. You wouldn't be able to plug in t to the second derivative, but couldn't you plug in an... Muy interesante. We're done. Okay. Homework number 10, section 4.1. It'll be on by the end of 5th period, aka by lunchtime, because I haven't put it on yet. Oh no, the chapter 4 homework is in the website. It's just not posted in classroom yet. Reflections, I want them. Reflections, grab them out. Do you guys find your names? Yeah, it is 3 times. It's only in there 3 times. Did you find all 3 of your names? There's a your name right there, there's a your name right there, and there's a your name backwards right there. Dun 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 dun. Huh? No, you're okay. That one? Oh, I'd have to do it. He has a box head. He has the little triangle, like the little dashy feet. He has his arms going out and up. Out and up, and then the ball, oh, I already did that one, didn't I? No, and the ball is a circle. Give it to me on your way out. Bye, guys. You gotta get out of here. You're having too much fun. Huh. That's fine. I'll just put it in your guys' tray, but I'll grab them from you now. If it's not ready right now, put it in the tray by the end of the day. Woohoo! Right there. There's too many people taking too long.